So last time we were looking at creating a university application. Okay, and I was supposed to give you an assignment, but I thought it would be better if I explained everything in the class. So today I will give you the assignment and it will be due next week. Okay? So anyway, the purpose of this assignment is to first of all have a good understanding of the inheritance issue. Okay, remember the purpose of inheritance was to write as less code as possible so that we can reuse the code. Okay, so purpose is code reuse. Okay, so inheritance only makes sense when we are creating many different classes, right? Okay, so as we discussed in the last lecture, in the beginning nobody knows what class to create. So you are given some kind of a requirement. For example, if you have to create an application for a university, you start taking a look at what are the physical things that exist in this university. So physical things that need to be represented. Okay, so obviously students are a big part of the university. So we have students, right? We have faculty, we have staff, we have buildings, we have dorms, and so on. So anyway, you can keep taking a look at, all the different things we need to create in our system. So then we further discussed last time. We may have many different kinds of students. So for example, we may have a part-time student, we may have an undergraduate student, we may have a graduate student, we may have a PhD student, okay, so anyway, once we have identified these are the things that actually exist, then we'll start creating a class over here, we'll start creating a class over here. Same way we'll go to staff and create a class for a staff. For faculty, we'll create a class, right? So anyway, as we start creating these classes, as we discussed in the last lecture, we'll realize ourselves we are repeating things, okay? So as I mentioned, anytime you're doing copying and pasting, a little bit of copying and pasting is okay, but if many times you're copying and pasting the code, then you're not doing something proper from good object-oriented programming point of view. So at that time, you should take out the code that is common and create what we call a base class, okay? So let me go to the computer, start creating some of these classes, and then the rest of those I will leave it for you to enhance and finish as an assignment. So okay, so once I'm in Visual Studio, I'll create a new project. So File, New Project. Okay, last time we already had created a folder called CS440 2015, I think. So CS440 fall 2015, right? Okay, so anyway, so location, I'll set it to our fall 2014. In case you run Visual Studio and you don't see the correct location of the main folder, you can always browse, create the folder if it doesn't exist, so that this part is, the location part is pointing to the main folder, okay? Then suppose we call this University App. Okay, so that's the name of the project. So we'll create a subfolder in this CS440 fall 2015. We'll select Windows Forms application, make sure the language is Visual C#, Windows Forms application. So anyway, name of the project, University App, location CS440 fall 2015. So once I click OK, we'll create some skeleton code for us. And then we will start adding classes to the project. And we can also write some test code as well. Okay, so if I right click on name of the project over here, the University App, then I will add a class to it. So if I right click on it, okay, add. Okay, so I can do it two ways. I can go add new item and then select a class, but if you take a look right at the very bottom, there's also an option to add a class. So I'll just pick a class over here. Okay, so let me start with the undergraduate student. Okay, so again, it doesn't matter which class you start out with. As we discussed, even if you started out with some class which doesn't make sense to start out, you yourself will recognize, you'll go back and adjust it, right? So let me call this class UG student. Just like Java and C#, if you create a class, the class name starts uppercase. So U uppercase, G uppercase, student, S uppercase, right? And that's a class, and so I'll click add. Okay. And at the bottom is the output window. You can always close these windows and bring them back. Once you run it, if you are displaying some output to the console, then this window will be needed. But so that we can take a look at more code, I'll close it, okay? And now let's start creating. Remember, as we discussed, all code we write should be inside a class, okay? At the very outside is the name of the namespace. So the last curly is end of the namespace, the second last curly is end of the class. So in between, we'll create some room. And let's decide what fields we wanted. Last time we discussed we will have a first name, last name, ID, test1, test2, right? So string first name. The default in C# is private, unlike Java where the default is public, okay? So private fields start lowercase, as we have discussed a few times before, okay? Then corresponding to this private field, if we right click, refactor, encapsulate field, it will suggest public property name with starting with a capital letter. And usually this checkbox will be checked. If you can uncheck it, because whatever suggestion it gives is pretty much always correct. So this will save you time. And now if you click OK, it will write the public get and set.
How do you do that again?
Right click on the private field, refactor, encapsulate field. If you have the, what do you call it, the community edition of Visual Studio, that option may not be available.
Okay.
So if that option is not available, then of course you can type it yourself. So then you will do something public.
There it
There's
is.
a
There in
quick
quick
action.
action. There under quick action.
There it is, even in the community action?
Or it is under quick action.
There is pen.
Okay, and how do you get to the quick action?
Right click on
Right click?
Instead of refactor, there is quick action.
There's a quick action? Okay, okay, all right. So good to know then. And then under quick action, is there an encapsulate field?
Yeah.
Okay. All right, so for the community edition, you'll go right click, quick action, and then encapsulate field, okay? So anyway, let me quickly go now and create all the remaining fields. So last name, and right click, refactor, encapsulate field. It will give you an extra blank line. I try to keep the private field and the corresponding public property together. So anyway, make sure above the last two curly braces you are adding the fields or the methods to the class. Now int ID. By the way, I forgot to mention one more thing. In C# there are what we call aliases, or think of it as another nickname. Okay. For example, string is actually a class in C#, very similar to Java. Okay. So there's two ways you can write a string. You can write a string with capital S, or you can write a string with lowercase s. Both are identical. So lowercase string with lowercase s is basically replaced by the class string once the compiler compiles it. Okay. Okay. So anyway, int ID. Let me refactor and encapsulate field. Okay, now if I go next one, int test1, and right click, refactor, encapsulate field. Okay, then int test2, and right click, refactor, encapsulate field. So all the 5 fields are there now, right? Okay, so now suppose as we were creating this, we also have a method to compute the grade of the student. So public string, so the method will return a string like A minus, B plus. So remember, before we write a method, we always indicate what is the return coming from the method. So in this case, it will be A minus, B plus, C, whatever, so it will be a string, okay? Followed by name of the method. Method names in C# start uppercase, unlike Java where they start lowercase, okay? And now we can create a weighted average. Suppose for an undergraduate student, double AVG equal to 0.4 times test1 plus 0.6 times test2. Okay, a minor comment over here. If I wrote test1 with a capital T, will that work?
Yes.
Yes.
Which one is better? Writing it with lowercase t or capital T?
Lowercase.
Lowercase, and the reason is because anytime we write capital T, that means it will go through the get function. So but we are already inside the class, so we have direct access to the data. So inside the class, you should always use lowercase variables. Outside of this class, if you wanted to know the test1, then obviously you don't have a choice. Then you will use uppercase T. Okay. Anyway, the if statement is written if AVG is greater than 90. Okay, before that, let me create a grade variable. So string grade equal to. It's always a good practice as you declare a variable to also initialize it. So two double quotations, no spaces in between. Okay. So if grade is greater than 90, sorry, AVG is greater than 90, let's say grade will be A. Else if AVG is greater than 85, let's pretend grade will be A minus. Okay, and else if ABG, else if ABG is greater than, let's say, 70, let's say grade will be E, and else let's pretend grade will be C. Okay, so anyway, after we have computed the grade based on what the weighted average is, 40% of the weight is given to the first test, 60% to the second test, right? And so now you will simply do return grade. Okay. Now, remember in C#, every statement is terminated with a semicolon. So some of you who are new to C-style languages have a tendency to put a semicolon also at the name of the function. Okay, so remember, because the function starts here, ends over here, so anytime there's begin curly, end curly involved, we do not put semicolons. So same thing when people who are new to C type of languages, they have a tendency when you're writing an if statement to put semicolon over there. Okay, it will not complain sometimes, but remember, if statement is continuing, because if this is true, then we should do this, else, you know, something else. So anyway, once we have written all of this function, compute grade, our class is ready. Okay, now as I discussed with you guys, and let me add one thing to that. Okay, for any class that you create, okay, you should provide two constructors. Okay, one is no parameter constructor, and two, a constructor with as many parameters as the number of fields in the class. Okay. So in our case, how many fields do we have? 5. So we'll provide two constructors, one without parameter, one with 5 parameters, right? Also, third thing you should do is provide two-string method. Okay, we haven't discussed this before. Okay, just like the name indicates, two-string means convert to a string. Okay, so in C#, like Java, the parent of all classes is object. Okay? So this is declared in a namespace called system. Okay, so sometimes people call it system.object. Okay, so object is the name of the class, and it is the base class or the parent class of all classes. Okay, remember, as we discussed, what does the parent class contain? It contains the common features of all the classes that will inherit from it, right? Okay, so the designers of Java, designers of C#, they sat down and they discussed what kind of capability that every class should have. Okay, whatever those functions are, those are moved in the base class. Okay, so in this case, they thought every class should have a two-string method. Okay, so what is the purpose of the two-string method? The purpose is to print out the values of the fields of a class. So for example, if we have 5 fields, right? And if you created a student with, let's say, first name John, last name Jacob, okay, ID 1, 2, 3, 4, test 1, 85, test 2, 91, right? Okay, so the idea is if we call, rather than calling the 5 fields one at a time to see what do they contain. If somebody called toString, they will give us the value of each one of those 5 fields as one string, okay? So that we can easily print it out and see what data does the object contain, okay? So that's why in the base class object, okay, so when they created this class called object, okay, one of the things they added over here is the toString method, okay? And so the signature of this method requires public string toString return. Okay, so something like this. So it doesn't do anything in the base class. Okay. Now, whatever class that we create, okay. So for example, we create a class called undergraduate student. Okay. Now, normally when we want to inherit from another class, remember the syntax we use is something like this, right? And then we'll start writing our code, correct? Okay, now, even if we do not say class UG student, so we take this out. We take this out. By default, our class is inheriting from the object class. And remember we discussed in inheritance, whatever is contained over here will automatically be available in the class that we are writing. So the default is, so let me also mention, okay, all classes in C# inherit from, or I should say ultimately inherit from, object class. Okay, so anyway, if I create a class called undergrad student, then where will it inherit from? Automatically from object. Okay. Now let me mention one more thing. Okay. C# has single inheritance, unlike C++. Okay, but same as Java. What that means is we can only inherit from one other class. Okay, in C++, we can inherit from multiple classes. Okay, so what if I did this? If I said class UG student, let's pretend I've already created a class called student. Okay, so then where is the undergraduate student inheriting from? Student, right? Now let me create a class called student. And suppose I do not say where it is inheriting from. So the situation is like this. Let me try to see if I can put all of these things on the same. Okay, so take a look at this screen. Student will inherit by default from where?
Object.
So will it contain a toString method?
Yes.
Because remember, object has the toString method, right? So it will also contain the toString method, right? Now let's go over here. Where is undergraduate student inheriting from? Student, right? So that's what I meant. See, ultimately, every class will inherit from the object class, because even though undergraduate student inherits from student, where does student inherit from? Object. So if there's a toString over here, will there be a toString in the undergraduate student? Yes, right? Okay. Now, what is this code doing in the base class? Returning nothing, right? What if we wanted to return over here the values of the 5 fields? So we will need to override it, right? So we will say public override string toString, right? And then we will provide our own code. So whatever the code is, code to return values of 5 fields as a string, correct? Whatever that code is. Okay, now we already discussed that. C# is a very strongly typed language in the sense that we cannot simply override something that we are inheriting. The class from where we are overriding from has to give us permission, okay? And remember, permission can be given through 3 keywords we discussed in the last few lectures. What were those 3 keywords? Abstract, override, and virtual, right? So my question is, in the whoever created this class called object, because they want to give permission to anybody who inherits so that they can provide a different code. So they have 3 choices. They can either put abstract over here, or they can put virtual over here, or they can put override over here. So let's go one by one and see which one of these makes sense in the object class. Override when we are already inheriting and we wanted to change the code. So will override make sense over here? Is object being inherited from something else? No. So how can we override? This is the very top level class. So override doesn't make sense. Let's go to abstract. Does abstract make sense over here? Remember, abstract we can only put
In the class of
if there's no code over here. Okay, see, abstract means no code, right? So in that case, if it was like this, where did it go? Oops. Okay, so if it was like this, okay, then abstract will make sense, right? We'll take it out because there's no code. But as I mentioned, whoever created this base class, they actually have some empty code in it. So does abstract make sense then? No. So abstract is out. Okay, so at the very top level class, as we had discussed, if we wanted to give permission to somebody to override, we have to put the virtual keyword, right? And then gradually I'll further explain what virtual means. It has a very special meaning. But anyway, so to summarize, in the base class, we have base class of all classes is object. Every class ultimately inherits from the object class. And because the object class contains this virtual method toString, now let's come to our third part over here. Anytime we create our any class, so for any class that we create, we will also provide an override of the toString method, okay? So that we can, however many fields we have, we can return the value of each one of those as a string, okay? So now coming to our code over here. So this is our student class over here, okay? So let's write the 2 constructors first. So first constructor, as I mentioned, will be without any parameters. And you can put no code over here, okay? So this is our default constructor, and the reason we want to put that is, as we discussed, as soon as we put a constructor, C# takes away this default constructor from us, okay? Now let's put a constructor with 5 parameters. So string fnm. It's up to you whether you call it fnm or f or just lnm or ln or whatever you wanted to call it, right? As long as it's slightly meaningful. Okay, so I should have a comma over there. Int id and int test1 and int test2. So those are the 5 fields for the okay, so anyway, those are the 5 fields. Okay, and now let's write this constructor. Okay, so our code will be take the first parameter and store it into our class variable first name. Same way, last name equal to lnm. And this dot id, because otherwise it will be a confusion which ID we are talking about. And this dot test1 equal to test1. And this dot test2, right? Even over here, even though there's no confusion, but there's no harm in writing this dot last name equal to lnm. So basically, whenever we use the this keyword, that means we are talking about the field of the class, okay? And this fnm is the parameter that's coming over here. As I mentioned, it's up to you what you wanted to call it, even if you wanted to call it fname as an example. Then make sure correspondingly this is called fname. So this has to match over here, right? So we've already written 2 constructors. Remember, constructor has the same name as the class name. And no return, right? So just a public. Okay, so we are done with this 2 constructors. What's the additional thing we have to provide in this class? An override of the toString, right? So again, it doesn't matter where I write this, in the beginning of the class or at the end of the class. Okay, let me go to the end of the class. Like I said, it doesn't matter. Remember, anything we add to the class will add above the last 2 curly braces. Okay. So now let me say public override. Okay, one of the nice things about C# is that we develop using Visual Studio, and it's a very friendly editor. It will give you suggestions. If you make an error, it will right away warn you by these red underline squiggly lines. Also gradually you should learn to be better at typing the code. So even if your typing skills are not very fast, it doesn't matter. As soon as you type partially, so for example, as soon as I say OV, right, you will see that it has already given us a suggestion that we're looking for override. And if you see that's correct, either you can double click on this part over here and it will type it for you, okay? Or if I go back and type OV again, hit the tab key on the keyboard. So if I hit the tab key on the keyboard, it will complete it, okay? So again, as I put a space, automatically it's giving me the suggestion. So can you guess where is this coming from?
Last one.
No, where are these methods coming from? Object class, right? Because remember, anytime we use override, that means we are overriding something we inherited, okay? Take a look at the top of my class. Did I say we are inheriting this class from anything? No. So by default, where it's coming from? Object. So that's why as soon as you write override, it will tell you what are the possibilities to override. So in the base class object, there's an equals method. There's a get hash code method. There's a toString method, okay? What do equals get hash code do? We'll gradually look into it. But for right now, we're interested in this, so I'll just double click on it and take a look at immediately completes the signature of the method, okay? So if you rely on Visual Studio, there's very less chance, rely on it for typing purposes, less chance of you making a mistake, okay? So base keyword we already discussed. What does that mean? It will call the base class method or access the base class field, right? So anyway, over here, we don't need anything from the base class. So we'll simply say first name plus, let me put one space in between, plus last name plus, okay. Now ID, remember the plus can be used to catenate strings, and what data type is ID? Int, right? Again, as soon as I type ID, will let me know right away through the IntelliSense. So how can we catenate int to a string? Okay. Now, one of the nice things is even the primitive data types have a corresponding class very similar to Java, so that you can directly call on the variable name, the toString method. As opposed to Java, where first you will have to encapsulate into an integer class before you will be able to call the toString on a simple int. Okay? So that's one of the nice things in C#. So anyway, anytime you have a non-string type of variable, make sure you call toString on it if you are building the string. So what about test1? toString. Okay, so again, the way I type it is I don't try to type the toString. As soon as I type T, I have a habit of hitting the tab key because it will automatically finish it, and all I have to do is left paren, right paren. Okay, remember if it is just a field like last name or test1, we don't need anything. But if we are calling a method, toString is a method, then we have to put the left paren, right paren after it. And let me put one more blank space, and let me say test2.toString. Okay, so our undergraduate class is ready. Okay, it has 5 fields. It has the override of the toString method, which is coming up from the base class object, and it has the 2 constructors, right? So once you are done with it, okay, let's pretend now you wanted to create a grad student class. So if I right-click on the university app, say add class one more time. So I right-clicked on the university app project, add, so this add menu, and then class again. And suppose now I wanted a grad student class. Okay. So now suppose we decided we will have first name, last name, ID, test1, test2, and we will have a thesis, right? So one option, as we discussed last time, is we go to the undergraduate student and copy and paste the code. So I start from here, from the constructor. So I'm copying the inside of the class, meaning I'm not copying the last 2 curly braces. And actually, I don't need this. So let me start again. Let me start from the constructor. So from the constructor, first constructor, and I'll stop above the last two curly braces and copy. And from the right side, if I double click on grad student, now inside the class, I'll paste that code, right? And now I will, remember we wanted one extra field, so you will say public string thesis, and then right click, refactor, encapsulate field. Okay. Okay, now you will notice sometimes what happens is, as you are putting the code, it becomes like misaligned a little bit, okay? So rather than you putting spaces over here yourself, or tab key, whatever, if any time misalignment occurs, just retype the last and closing curly brace. So if I backspace on it, retype it, and if I go up, oh, it didn't fix it. Is there a problem over here?
Constructor name.
Oh, I see. There's an error in the top, so that's why it didn't fix it. Okay. So now remember, we will do grad student over here. This one we will do grad student, correct? Okay. Then we will add the sixth field over here, because now we have string pieces. So anyway, so that's one way of creating the grad student class, right? But since we copied and pasted a lot of the code, as we discussed in the last lecture, you will realize it yourself that we are copying and pasting. So what's the better option? Create a base class and take out all the common things, okay? So now let me right click on name of the project and say add new item. Pick a class and let me call this class full-time student. Okay, and click add. Okay, and now paste all the code that we had from the student class over here. So I pasted all the code from the undergraduate student over here, and now let's change it. Okay, so this will act as the base class for undergraduate student and grad student. So the first constructor will be full-time student. This will also be full-time student. And let me leave all the 5 fields over here. Okay. So we only picked the common fields. So we did not put thesis over here. Why? Thesis is not in the undergraduate student, right? Remember, only with the fields or the methods that exist in both classes we'll put over here, okay? Let's go to the toString method. Is toString method correct? Yes, right? Okay, so now let's also talk about, should we mark this class abstract?
Yes.
Yes.
And the way you decide is there an actual student which is a full-time student?
No.
No, right? Because either it's an undergraduate student or grad student. So this is just for the purposes of code reuse. So we don't want anybody to be creating an object of the full-time student. So that's why we'll mark it as abstract. Okay? It is okay to have an abstract class and still have real code in the constructor, real code in some of the methods. It's okay to do that because, once again, our purpose is to reuse that code. That's why we are marking it abstract, right? So now let's go to the undergraduate student class. Okay, so in the undergraduate student class, okay, where will we inherit it from?
Full-time student.
Full-time student, okay. And by the way, class names, if it's a recognized class, it will appear in light blue color. If it's a keyword, it will appear in blue color. So gradually, hopefully, you'll get used to the terminology or the color coding. Okay, now let's go to the constructor for the undergraduate student. will it have 5 fields? Yes, right? So here's the part which will be different. Okay, rather than us writing the code and initializing each one of those 5 fields over here, because there is a constructor in the base class which already initializes this, right? So our work will be less if we delegate the work to the base class constructor. So how do we delegate the work to the base class constructor? We put a colon and we say base, f name, comma, lnm, comma, id, comma, test1, comma, test2. Okay, so the requirement is, and now I don't need this code over here, so we will delete that. Okay, so anytime we want to call the constructor of a base class, the requirement is it has to be done in the very beginning, before we write any code. So this is called the initializer list. So the concept is very similar to C++. Okay. So at the very top we will say base. So this way it's guaranteed that as soon as this constructor is called, it will trigger the base class constructor and everything will be done. Okay. So we don't need any code inside the method. So only for constructors, this is the technique for triggering the base class constructor. After the name of the constructor, put a colon and then base. Okay. Now let's go to the remaining fields. Do we need first name in the undergraduate student?
Yes.
Remember, it's coming from
Base class.
we already inherited from full-time student. It's already declared over there. So do we have to redeclare it?
No.
No. So we can highlight and delete. What about last name?
No.
ID coming from, again, the full-time student, right? Test 1, test 2,
No.
compute grade.
No.
Okay, if our formula for the full-time student is still 40%, 60%, then this is already there in the full-time student, so we don't have to type it also, right?
Yes.
So I'll delete it. Let's pretend the undergraduate's formula is also same. So anyway, as you can see, our code for the undergraduate student is very small, okay? Okay, so basically 2 constructors, correct? And then the override. Okay, however, it's not recognizing first name, last name, ID. Oh, the toString also, remember we had a toString in the base class, full-time student? So why rewrite that code?
Return based or toString.
Yeah, so we can easily delegate the work to the base class by saying return base.toString. Now, who's the base class for
Full-time
undergraduate student?
Full-time.
Full-time student. So which toString will it call?
Full-time student.
The toString in the object class or the toString in the
Full-time student.
full-time student? So we'll call the toString in the full-time student, right? Okay, now let's go to the grad student class. Okay, in the grad student now, where will we inherit from? Okay, so now let's go to the second constructor. We will delegate the work of the initialization of the first 5 fields to the base class constructor. So colon base, and what will we say? Name, comma, lnm, comma, id, comma, test1, comma, test2. Can I also say comma thesis?
But we should define it.
No, because the base class, which is the full-time student, only has 5 fields in its constructor. So that means we have to initialize the thesis of ourselves. So we can simply say this dot thesis equal to thesis, right? Everybody agrees? Okay, so now let's go to the fields. Do we need first name? last name? No, they are coming from where? Full-time students, so let me delete. Do we need thesis?
Yes.
Okay. Now let's pretend for grad student also the formula is 0.4, 0.6. Even if you had a different formula, what will you do? Override it. And if you wanted, let's say 0.5 over here. And 0.5 over here, that's okay. We'll simply override it. Okay, so now the problem is with test 1 and test 2. How come it's giving us an error? If you put your mouse on it, it will say is inaccessible due to its protection level, meaning public-private issue over here. How was test 1 declared in the base class? Private, right? So if I go to the full-time student and take a look, default is private, okay? And remember, if we wanted it to be accessed by the derived class, we have another keyword called protection.